Let's determine whether this series converges or diverges. Now you might already have some intuition as to how to solve this, or what test to use, but if not, we could start by plugging in the first few terms and detect any patterns that we see. So if I first plug in n is equal to 0, I know that this term will go to 1, so I'm left with 4. And then if I plug in n is equal to 1, then I have that 4 again, this time multiplied by 3/4. And then if I plug in n is equal to 2, I have again that 4 that's still there, times that 3/4, this time it's squared, and so on. So what I'm noticing here is I have that first term, 4, and it doesn't change, and it's always there. And then it's also always multiplied by that ratio 3/4. It's even multiplied in this part over here, but it's raised to the power of 0. So when I see this pattern, when I see that I have that first term multiplied by a common ratio, I'm going to be using what's called the geometric series test. What the geometric series test tells me is that when I have that common ratio and it's less than 1, then I know that my series is going to converge to that first term over 1 minus r. So that's basically what the test is. However, if my ratio is greater than 1, then I know that my series will diverge. So I already know that my ratio here, my common ratio, is 3/4. And 3/4 is less than 1, so I know that my series is going to converge. All I have to do now is just do the test, carry out the test. So basically just plugging into this test, I have my initial term, which is 4. I know some people like to factor out the initial term, and that doesn't make a difference. You're always going to end up with the same answer as long as you don't forget about it at the very end, over 1 minus my common ratio, which is 3/4. Doing the math, you end up with 4 over 1 over 4, and that leaves you with 4 times 4 basically. And so you're ending up with an answer of 16, and that basically tells you that your series converges to 16. And that's it.